So here we are going to see the questions from CBSE sample paper, latest 2021 to 22. First question. Which of the following is not the property of equipotential surface? 4 options. They do not cross each other. The rate of change of potential with distance on them is 0. For a uniform electric field, they are concentric spheres. They can be imaginary spheres. So this is about equipotential surface, property of that. Which of the following is not the property? So we'll have to take them one by one and check whether it is the property of equipotential surface. First, see, they do not cross each other. In fact, equipotential surfaces do not cross each other. So this is the property of equipotential surface. Why? Because see, no two electric lines of force will intersect. We know that two lines of force, electric lines of force, suppose this is one electric line of force, this is another line of force, they can't intersect. Intersection not possible. Why? Because at the point of intersection we can draw two tangents. That means there are two directions for the electric field, which is not possible. Also, electric lines of force are perpendicular to equipotential surfaces. So if electric lines of force or electric field lines cannot cross, means equipotential surfaces also cannot cross. So this being the property, note that electric line of force or electric field line should be perpendicular to equipotential surface. Electric field lines cannot cross. So equipotential surfaces also cannot cross. Okay, so we say that this is the property of the equipotential surface. But we have to find out which is not the property. Okay, so we'll have to be very careful. Then the rate of change of potential with distance on them is 0. This is again the property. Suppose this is the equipotential surface. Then potential here is V, means potential here also should be V. Then only you can consider this as equipotential surface. Equipotential surface. This is by definition. Equipotential surface, this is by definition. What is an equipotential surface? An equipotential surface is one such that all points on that surface have same potentials. So there is no change of potential, hence there is no rate of change of potential. So this is also the property of equipotential surface. Then for a uniform electric field, they are concentric spheres. For uniform electric field, equipotential surfaces are planes. For equipotential surfaces, for a uniform electric field, the equipotential surfaces are plane. Okay, see, you can consider here. This is uniform electric field. They are equally spaced, you know. This is uniform electric field. Uniform electric field. So these are all equipotential surfaces. Equipotential surfaces will be spherical in the case of point charges and not in the case of uniform electric field. Therefore, this is not the property, and this will be the correct answer, because we have to give the answer which is not the property of the equipotential surface. The answer should be not the property. So option 3 is correct. Of course, you don't have to check for option 4 because it is only one option. We have to choose which of the following is not the property. Therefore, option 3 is correct. So the given answer, official key also for answer 1, that is for question 1, option 3 is the correct answer. Question number 2. 2 point charges plus 8q and minus 2q are located at x is equal to 0 and x is equal to L respectively. The point on x-axis at which net electric field is 0 due to these charges is option 1 8L, Option 2 4L, option 3 2L, option 4 L. So we see how to answer this. At x is equal to 0 and x is equal to L. So let's say that this is the x-axis. Let's say that this is x is equal to 0. Say this is x is equal to L. Move A. At x is equal to 0, you have got a charge 8q plus 8q. It is explicitly given plus 8q. Then at x is equal to L, you have minus 2q. So the charge here, so at this location, minus 2q. What you have to find out? The point on x-axis at which the net electric field is 0. Suppose you consider the point, say somewhere here in between the two charges. Let's say you consider a point P. Then at P, field due to this plus 8q will be in this way. At P, field due to this minus 2q will also be in this direction. So the two fields are in the same direction, so they cannot give you zero electric field. For giving zero electric field, the two electric fields should act in opposite directions. Therefore, the point where the electric field, net electric field is 0, cannot be in between O and A. Is it clear? Therefore, it has to be on the other side of A. That means it should be greater than L, obviously. Okay. So you consider now the point P somewhere here. As per the key, okay, the point P, you can take the point P to be at a distance R, okay, at a distance R. That is this distance, okay, this distance is R as per the key. Now net electric field at P should be 0. So that is possible when the two electric fields are in opposite direction. So at P, electric field due to this plus 8q will be this way. Okay. So you can call this as E1. Then at P, electric field due to this minus 2q, because of the attractive force, the electric field will be like this. Please remember, always the electric field at a point will be away from a positive charge and towards a negative charge. So you will have to imagine a positive charge here. That positive charge, imagined positive charge, will be repelled by this. So electric field at P is away. Similarly, if you imagine a positive charge due to this minus 2q, that field will be, that a charge will be attracted. So that electric field will be this way. You can consider it to be E2. Now E1 and E2 should be equal in magnitude and opposite in direction. So E1 is what? Due to plus 2q. So K into 8q by this distance, all the distance, that is distance OP. Please remember, the distance OP you can consider it as R plus L, because AP is R, OA is L, so OP is R plus L. So OP square should come in the denominator, which is R plus L whole square. This is magnitude of E1. That should be equal to magnitude of E2. So K into 2Q. I said magnitude, so I am not putting minus 2Q here, by this distance, which is R squared. After that only main cancellations are there. Okay. So we can cancel out the common things. K will go. This Q will go. Correct. Then 8 by R plus L whole square is equal to 2 by R square. Of course there is 2 here, so this 2, this 8 here, so this is 4. Okay. Then 4 by r plus L the whole square is equal to 1 by r square. Now take square root, this becomes 2 by r plus L is equal to 1 by r. Okay, now cross multiply. 2r is equal to r plus L. 2r minus r is r, so r is equal to L. So this is r, that is equal to L. But the question says the point on x-axis at which the net electric field is 0 due to these charges is. So you will have to give the distance from the origin. Okay, this L is from A, but you have to give OP, distance OP. Therefore distance from the origin happens to be, that is OP, okay, is equal to L plus L, which is 2L. Okay, so the answer is 2L, which is marked here, as per the question. Key is given, so according to this key, R is L, but we want the distance x, so that is 2L from origin. So correct option is option 3, which is 2L, see, which is being marked here as 2L. Okay, question number 3. An electric dipole of moment P is placed parallel to the uniform electric field. The amount of work done in rotating the dipole by 90 degree is option 1 2 PE, option 2 PE, option 3 PE by 2, option 4 0. Here P is the electric dipole moment, it is given here. E is of course uniform electric field. We have to find the amount of work done and check out of the 4 options which option is correct. So work done formula, here you see answer is option 2, this is explanation. Sorry, answer is second option. Answer for question number 3. It should be answer for question number 3, option 2. Work done is PE into cos theta 1 minus cos theta 2. This is a formula for work done. Initially it is parallel, so theta 1 is 0 degree. After that it is rotated by 90 degree. The amount of work done in rotating the dipole by 90 degree is. So theta 2 90 degrees. Substitute theta 1 0, theta 2 90. Simplify. Cos 0 is 1, cos 90 is 0. You will have to be very careful. Students do mistakes in that. Cos 0 is 1, cos 90 is 0. So 1 minus 0 is 1. So PE. So option 2 is correct. This is fine. You can also do this problem by using the expression for potential energy. So use the expression for potential energy. We know this formula, minus P dot E. You can even do this problem by using this formula. Suppose if you forgot this formula, if you remember this formula, you can proceed. You know that work done is change in potential energy. Okay, that is final potential energy minus initial potential energy. This, when you simplify, you will get minus PE cos theta. Theta is the angle between dipole moment and the electric field. So coming here, final, how will be the final one? Final one is dipole is making an angle of 90 degree. If you want to draw the picture, it will be like this, minus Q plus Q. This is the electric field, this is 90 degree. This is final. What is the initial orientation of the dipole? Along the direction of the electric field. So minus Q plus Q. Okay, this is the dipole moment. Okay, Now final is this. In this you will have to put theta 90. So final, because theta is the angle between the electric field and the dipole moment. So theta is 90 finally, because you are rotating from this position to this position. So finally it is theta is 90. So cos 90 is 0, minus PE into 0 is 0, minus initial. What is initial? This one. Initial position means this one. Theta is 0. But theta 0, you will get minus PE. Cos 0 is 1. So you will get minus PE. So minus of minus PE is PE. Same answer you are getting. So correct option is PE, option 2.